What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to practice finding more limits algebraically, this time with functions like this, which I call complicated fractions. Okay, and funny enough, I came across some examples like this when I was practicing, studying, refreshing my calculus skills, and I completely forgot these were a thing. These weren't in my video plan, and I didn't put them on this flow chart here, but here's where they fit in. It's like another one of our methods, right? So we can say complicated fractions, and I don't even really know if there's a formal name for this, complicated fractions. But here's a good chance to think about, what do all these methods have in common, right? They're what we do after we get 0 over 0. We always start with direct substitution. If we get 0 over 0, that means we have to investigate. It means there could be a hole, the limit could exist. And what do all these have in common? They involve doing some kind of algebra. They involve removing a discontinuity, right? Canceling a factor and producing a new expression where the function is defined at the value x is approaching. So we can plug that number in and that's going to give us the limit. Graphically, we can think of it as we are creating a new function where the whole of the original function, where it was undefined, is now filled in, and we're finding the y value of that whole, which is the limit. So we're doing essentially the same thing here. And how can we think about what we're doing algebraically? Well, just ignore the limit and ignore the equals and think back to like algebra 1, intermediate algebra, whatever class you took, and think about if you were given this expression and told to simplify it. It's probably the same thing you would do to find this limit, given that it is indeterminate. First, we got to check that. Awesome, let's try it. Direct substitution is how we always start. 1/2 minus 6 over 9 plus 3. Let's see, what is 6 over 12? That's 1/2, that's 0. 1/2 minus 1/2. And then 9 minus 9, 0. Boom, indeterminate form. All right, here's what we're going to do. I know at least two methods I've thought of. One is that I can multiply the entire numerator and denominator by the least common denominator of these two fractions in the numerator. In other words, the least common multiple of these two denominators. Why would I do that? Well, because it's going to get rid of all the fractions in the numerator, right? And that's always a good strategy. Getting rid of fractions is great. So let's try it. What is the least common multiple of these two denominators? Well, they currently don't share anything in common, 2 and x plus 3. So we're going to multiply by the product of them, 2 times x plus 3. All right, what happens when we do this? We have to make sure to also do it in the denominator, 2 times x plus 3. Right? Otherwise, we completely change the function. Here's what's cool about this. Works like magic. We got to distribute. Boom. What happens when we multiply here? The 2's cancel. Again, like I said, fractions are gone. We just have x plus 3 there. Minus. Now what happens when I do this? Boom. Fractions are gone. X plus 3 over x plus 3. So I'm just left with 2 times 6, which is 12. Amazing. In the denominator, what do I have? Let's be careful. X minus 9 times 2 times x plus 3. So I like to write the constant out in front, the number, and then write the factors after that. Just personal preference. X minus 9, x plus 3. All right, this equals what? We can combine a like term in the numerator. Plus 3 minus 12 is minus 9. Boom, and just like that, I already see what's going to happen here. We have this x minus 9 over x minus 9, right? And so now here's exactly what I said. By removing the discontinuity, we're producing a new expression or new function that has this discontinuity removed. And we got to be real careful. Students love to do this and then plug 9 in and then write 2 times 12 as the answer, 24. That's wrong, right? This is in a denominator. When we cancel like this, there's a little 1 up here we can place up here. So we can say this expression is going to give us the y value of the whole. It's going to give us the limit. And I think I just gave away what it is, 1 over 24. Let's double check. 9 plus 3, 12. 12 times 2, 24. Yes, 1 over 24 is this limit. Awesome. Hopefully that made sense. We got 2 more examples. So now's your chance. Pull out a pencil and a paper. Try this on your own. Pause the video. I'm going to apply the same strategy again. This time we have fractions in the denominator. I want those fractions to go. I want them to be gone. So what can I do? I can multiply by the least common denominator. They share nothing in common, so it's very similar to the last example where it's 2 times x minus 5 and 2 times x minus 5. We're doing that to the numerator and the denominator. All right, let's distribute. Boom, what happens? All right, in the denominator, maybe I'll start with the numerator actually. I'll just write that out. All right, so again, I can write the 2 out in front. That's just how I like to do it. Here I have 3x minus 9. Hopefully I'm giving myself enough room. All right, in the denominator, what I have, these x minus 5s are going to cancel. Boop, boop. I'm left with a 2 times x minus 8. 2 times x minus 8. And then minus, got to be careful. All right, the 2's are going to cancel. Minus 5 times x minus 5. Awesome. All right, how are we going to simplify this? Okay, so here's what I'm going to do. I'm going to combine all the stuff. Let's see, is that what I want to do in the denominator? Do I want to combine all the stuff? Yeah, because right now I can't cancel at all. There's 2 terms here, right? So I need to either factor, but since these terms are not common, if these were like both x minus 5, I could factor. But we don't have common stuff here. So I think I just need to combine it all. Let's try it out. I'm going to write 2, 3x minus 9, x minus 5. All right, let's see if I can combine all this stuff. All right, I'm going to have 2x minus 16 here. And then I'm going to have minus 5x plus 25. All right, sick. I think I see how this is going to work. All right, we have 2x minus 5x. That's negative 3x here. So in the denominator now we have 2x minus 5x. That's negative 3x. And then we have minus 16 plus 25, which is plus 9. Amazing. Now I see what's going to happen. Look at the connection between this and the stuff in the numerator here. Looks very similar to this. The only difference is that the signs are opposite. Here we have minus plus, here we have plus minus. So what we can do is we can actually factor a negative out of here. So I can write that 2 as negative 2. And then I can change this to minus 3x plus 9. Yep. Let's double check. When we put in the minus, I get plus, minus. Yep. And then the x minus 5 is chilling out in front. Awesome. So now we can actually cancel that out. We are producing a new expression. Boom, boom, where that whole is removed. Now we can find the y value of the whole, which is the limit. So let's do it. 3 minus 5, negative 2. Negative 2 times negative 2 is positive 4. That's the limit. Awesome. A little more complicated than the last. All right, let's try the third one. Do I want to do the same method or do I want to switch up? I think I'm going to switch up. Here's the other method I know, which is actually not only find the least common denominator, but just combine these fractions. And then we're going to rewrite this. Instead of dividing by this, we're going to rewrite it as multiplication times 1 over 2x minus 8. And then you can tell me for yourself which method you prefer. All right, what's the least common denominator? Well, they shared nothing in common. So it's 5 times x plus 6. So we're going to multiply this by x plus 6 over x plus 6. And we're going to multiply this by 5 and 5 in the numerator and denominator. Is that right? Yep, looks good. All right, what do I get? In the numerator here, I get 20, 5 times 4, minus 2 times x plus 6. Okay. And in the denominator, I get 5 times x plus 6. That's how subtraction works. We keep the denominator the same once they are common. Amazing. And now I can rewrite this divided by 2x minus 8 as times 1 over 2x minus 8. So now all I think I have to do is distribute this negative 2 and then see what's going on here. I have a feeling something's going to cancel here. So when I distribute this negative 2, what do I get? Minus 2x minus 12. All right, do I need to rewrite that out? I think I can just write it here. Minus 2x and then minus 12 because I want to have enough room. So I'm having to be creative here. So I have 20 minus 2x minus 12, which is 8 minus 2x. Oh, amazing. All right, that's what's in the numerator, times 1, so that's chilling. And then the denominator, we have 5 times x plus 6 times 2x minus 8. Look at this, similar situation. How do these differ? Well, this is the same thing as minus 2x plus 8. So it's the same situation as the last example where they differ by a factor of negative 1, right? So what that means is I can erase 8 minus 2x and I can rewrite it as, let's see, instead of 8 minus 2x, that's what I had before, so I'll leave it over here so we can compare. I can write negative 2x plus 8. And now we have something that's going to cancel. Amazing. This is so much fun. Cancel this. cancel this. -1 chilling out here. Now when we plug in 4, we get 4 plus 6 is 10. 5 times 10 is 50. -1 over 50. And that was our last example. All right, and that's going to be it. I had fun with these. They're pretty fun. Throws me back to doing some algebraic manipulation, Algebra 1 type stuff. Hopefully you enjoyed it. Leave comments below if you have questions. Like the video, subscribe, do all that stuff to support. But most importantly, keep flexing those brain muscles. I'll see y'all later.